So with the discussion of naive versus primed, one of the key hallmarks of naive, especially if the cells are female, is that both X chromosomes are active. So have you looked at X chromosome status in your cells?
Short answer is no, but that's one, as you said, that's one of the defining characteristics. We're focused actually on demonstrating germline transmission. We think that'll bring the money in.
Okay. Questions? Anyone?
Building on that, Mark, didn't you say something in your talk about that the female cells don't go germline, but you said that there was a reason for that, and what is the reason for that?
That's a good question. We know from the stuff we did a long time ago in mice, and other people have shown this too, that female ES cells tend not, well, about 20% go germline when you make the chimeras. Whereas for males it gets closer to 100%. And probably 10 years ago now we did a similar experiment in pigs where we took inner cell masses from male and female embryos and showed the same thing, that we made lots of male chimeras and 100% went germline, and in the females I think it was closer to 20%. So I'm not sure the reasons for that, to be honest. It depends on the sex of the embryo that you put the cells into too. So there's probably a few PhDs there. So I don't have the answer, sorry.
Could it possibly be, though, if you've got cells that are supposed to have two functional X chromosomes and only one is active, that's why they're not going germline?
Yeah, I think if you put 2 and 2 together, and I think you come up with 4. So I tend to agree, but we haven't done that.
Questions?
I've got one while the audience are thinking of one, because I'm sure they've got one in a minute. I guess the common themes across all of the talks were that not all stem cells are the same, that what you capture is perhaps a sneak peek at just a single point in time, and that you need to analyse multi-layers. So if we don't have time to read the whole library, which book should we read? You know, what should we all be working on something common, or is there, you know, or is the diversity and the 500 cell lines representative of the fact we need to explore everything? And I guess the question can go to anybody.
Well, my perspective is the more varied the models that we have available to us, the more useful the books are that we have available to read. And I think this is an area where interspecies comparisons are particularly valuable, because it tells us that the networks around pluripotency and differentiation can form in a multitude of ways. And so comparisons of these will help us identify those features which are really critical through evolutionary pressure for maintenance of pluripotency, and those which are expendable or can be swapped out, and that's hugely exciting.
Anyone else?
I guess my perspective is that I would argue that reprogramming, as essentially defined in an artificial model by Yamanaka, also occurs in the embryo, in the germline. And so I think you need to cast the net wide enough across enough different mechanisms to see the true value of functional understanding. So we can obviously get a good understanding of reprogramming in germ cells, which every generation undergo this process of epigenetic reprogramming. That will complement what happens in stem cells indeed. Some of Sarani's work early was focused on using germ cells as a model of reprogramming, as well as using pre-implantation embryo stem cells to look at the same processes.
I'll just add one additional comment. I think it reflects the fact that in recent years we've seen the emergence of a huge number of databases where we're looking at transcriptional profiling and epigenetic marks in a wide range of tissue types and cell types. We can think of the ENCODE project, the NIH Epigenome Roadmap project, the Phantom project. I mean, the list goes on and on. And I think that these present an incredible opportunity in terms of being able to find mechanisms that are common. If we take a wide range of cells and tissue types, trying to understand common mechanisms of biological function versus cell type specific function, and having perspectives from a wide range of diverse cell types and tissue types, disease types, etc., gives us really an incredible opportunity at this point to be able to make some great headway. And so I think the diversity is a great opportunity at this point, and I think we've seen the emergence of a large number of data sets out there that are enabling us to be able to study this more effectively.
But, you know, adding on to that, whenever we, in the Phantom Project, whenever we add in extra cells, particularly transitioning cells, we find new things. And we're really good at capturing the molecules which are abundant in steady state. And we're only really just now starting to understand the molecules which are transient in rare cell types. But these are probably the molecules which are really critical for understanding how a cell changes to become something else, a lineage specification. So there's a lot more that needs to be done.
Nothing? All right, I'll go. Oh, yep, go on at the front.
Within pig ESLs, do they have, what sort of morphology, the colony morphology of those? Are they rounded? Are they flat?
No, they're flat, but my ESL physiologist explains that because what you're alluding to is the mouse are domed. Naive cell, mouse ESLs that form dome colonies. But if you look at the embryogenesis between the two, they're different. And this is where it gets a little bit confusing, but basically he's saying that the way gastrulation occurs in the mouse is different to the pig, and that's how he explains that the two colony morphologies are different.
And have you thought about looking at taking human ESLs and exposing them to the naive reprogramming cocktail and seeing how they compare to your pig ESLs?
We'd like to do all that and more, but we haven't done that yet. We'd actually like to go and isolate, or look at this cell type in humans, see if we can isolate the same cell type in humans. So that's one of the one of the nearer aims, I think, for the work is to go and isolate that cell type in humans and then compare it with the naive and the prime cell types that are out there.
I have a question for Patrick. For those mice that were underweight at birth, do they actually catch up later in life?
So from our work, we don't actually know yet, at least in the enhancer as S2 model. We do know that for the EED weight difference, that is maintained actually for quite some time. From the study of Sarani early on, the enhancer as S2 mice do catch up by about 30 days of age, and so that looks like a true fetal growth phenotype that's then resolved to some extent during the early stages of life. But we know from human studies also, or human patients who are born underweight or overweight, that this can also lead to substantial issues later in life and susceptibility to particular metabolic differences, etc., through life.
With the availability of cosmetic surgeons, there's no shortage of the public going to these people, paying a small fortune, and these people are obviously quite desperate. We've been talking about stem cells as the panacea for all sorts of problems for a heck of a long time. We now have these wonderful molecular tools available. Are we actually any closer, really, to delivering really good outcomes for people?
Well, I'll take a stab at that because it is extraordinarily complicated issue at hand. I think that you articulate that extremely well, and I think that there's it depends on I think if you take into account the efforts in the adult stem cell field, like the mesenchymal stromal cells and all of the efforts that have gone into trying to treat various diseases using those intravenous injections of MSCs, and to some of the more recent efforts in trying to use embryonic stem cell derivatives to try and regenerate different types of tissues, or as a model for being able to treat diseases. And so I'm not sure if we're closer per se. I'm not sure that I'm going to get on that bandwagon to say that we're very close. I've certainly been on teams of people that have been working toward regenerating the heart and putting cardiomyocytes that we derive in the lab right into the heart or the myocardial wall to help remuscularize the tissue. And certainly those kinds of efforts are moving forward into clinical trials. But again, when even you say clinical trials, we're still talking efficacy, safety issues, and it goes on years and years down the line. And so I'm going to say that, you know, it's there's still something to be realized, I think, in the world of stem cell biology and regenerative therapies, and it's going to be a long road. So I think that my message to the public is just I hope that this one of us anyway was talking about this. The issue of making sure that we get the questions right the first time and getting some knowledge about the basis of these therapies, not jumping in too quickly, which has happened in many cases when you talk about gene therapy or cell therapies. People jump in very quickly. And taking the time to get the biology right. And I think that we talk about these kind of therapeutic panaceas from the very start, and so then the public gets very excited about it with the expectation to be proximal, but that's not going to happen. So I'm not going to put a timeline on it, but I'm hopeful. So that's what I would say.
I mean, I could add to that too, that it's really the problem with these unproven cell therapies. And you know, in Australia, there's been a recent study published, there's 19 clinics operating with unproven cell therapies. Someone died last year, and through negligence, really. And in the reproduction field, out of those 19, one of them is treating infertility. And I recently heard at a conference that there's another person, I don't think it would have been counted in that, well, I don't know, but treating women for vaginal atrophy with liposuction fat. And the problem with this sort of thing is that if something goes really wrong, it sets the field right back. And it needs all the kind of studies at all the different levels that we've heard today, from the very, very basic understanding of what's going on in the cells and before we go into the clinic. It really does need careful work. Otherwise, like the gene therapy got set back when something went wrong. So, you know, it's a difficult area because the media really hype it up quite considerably. And there's people really ready to exploit that, not really caring about the patients. I mean, the clinician I heard speaking, just treating women, when he got questioned about what kind of selection criteria, dose, what kind of clinical assessments and other assessments were done, he didn't have any answer. So women are being treated, in this case, that's sort of an area that I know about, for things by clinicians using cells like fat when they really don't have any idea. They're not gynecologists, for example. They're often cosmetic surgeons treating all these sorts of things. They do not have the basic background in that area.
We have to draw a very strong line between clinical trial for stem cell treatments which have got a very solid scientific basis behind them, and where those clinical trials are followed and reported, and not just reported in the short term, but where there are long-term follow-ups afterwards. There are a large number of operators who do not have any kind of clinical trial backing what they do, or they have superficial phase 1 trials which are used as marketing tools. And we must not give these people the benefit of the doubt when we say stem cell therapy. They are not using stem cell therapies, they are using unproven treatments, and they are adopting the term stem cell and misappropriating it. And that's a very important point that we as scientists must state very firmly publicly.
I also just want to make a point, a shout out to the International Society for Heart Research, which has been one of the leading societies to make publicly available resources for people to actually identify these kinds of clinics that are doing cell therapies without any scientific basis, and trying to increase the public awareness about them, because I think they are misleading. So if people are interested, I think the ISSCR has really excellent public resources to be able to understand this a little bit more.
That's why these forums are important, though, because we have people now that are participating in stem cell tourism, going overseas. And there was a paper, I think, in the New England Journal of Medicine about somebody that got a mixture of 3 cell types, one including embryonic, and ended up with a large tumour as a result. So it's important that the public understands where this research is at. So this is why this session is important.
So then perhaps to follow on from that, we are being encouraged to push the translation boundaries in terms of grant writing, and the media encourages us to sell every paper and every story with a headline about how we're curing infertility, or in your case, changing the world of stem cell therapy. What can we do as scientists to help the media get the right information? And as experts in the field, what would you encourage us to do, the rest of us who are not necessarily stem cell experts, but what would you encourage us to do to get the right messages, continue to get the right messages out there, so that people don't continue to pay for these kinds of treatments, which we know are potentially very dangerous and not efficacious?
I think one of the things is that we really have to educate people to get resources so that they know what to go and ask their doctors, for example. And Nathan has mentioned ISSCR have a very good website and a very good resource. There's resources available in Australia on the Stem Cells Australia website, and also the National Stem Cell Foundation of Australia as well. But if the thing is, if you're paying for a clinical trial, if they're saying it's a clinical trial, which is what they do at times.
Yeah.
If you're paying, you don't pay for a clinical trial, okay? And if there's no follow-up, and it's really even the assessment of the patient before they even receive the treatment, if all those things are not met, people should not take those treatments at all.
I mean, the difficulty here, of course, is that these are cells we know very little about, and clearly there's a large amount of basic research which is needed. And so I think that we have to be educating our funders that translation needs basic research, and that's something that I'm probably preaching to the choir here, right? But also, our young stem cell researchers need to be aligning themselves with clinical need, because there are clinical gaps that can be addressed with stem cell therapies if we can get the clinicians and the stem cell researchers speaking together. And then the third aspect, I think, is it's all very well that we stand up and provide information to the general public, but, there's a huge demand for therapies for where there are no good clinical approaches at the moment. And people with chronic pain, or who have got degenerative diseases, or who are paralysed, are really very impatient, and understandably so. So I think it's equally important that we have a two-way conversation with patient communities to understand why they're seeking these therapies, and rather than just us telling them why it's bad, actually learning from those patients about why they're going.
You have a question. Don't know where the mic went, though. Oh, there we go.
Is stem cell therapy regulated by the TGA?
That's part of the problem.
No.
I think it's not.
So autologous stem cell therapy, if the cells are not expanded and treated in any way, gets through a TGA loophole, because you're taking the patient's own cells and putting them back.
And not even the fact that you might be processing it in the back, in the kitchen over the stove matters.
These are uncharacterised. This is uncharacterised material going back, which is why I emphasise they are misappropriating the term stem cell treatment.
I realise that,
But if you are doing allogeneic therapy or you are producing a stem cell product, and we have some very good bona fide stem cell pharmaceutical biotech companies here and some genuine people doing clinical trial, those people are regulated by TGA.
Well, is it not worth asking the TGA that autologous stem cell therapy, the regulations have changed?
Yes, and I think that we could all add our voice to that. That's an ongoing conversation with TGA.
I think that another critical issue is actually the way that science is understood in the public domain, and particularly at the political level. I think in Australia recently we've gone through a time, and probably presently, where politicians are not understanding the way science is done and what scientific evidence means. And this is then trickles down to the public. I think it's critically important for science in general that we get the message across about how we do the work and what the evidence means, not necessarily on a specific topic, but generally speaking, that we build blocks, we perform basic research to understand on an evidence basis to make progress. Just like building a car engine, for example. We know you can't make a car go without a particular process to build that engine. We should know that you can't make stem cells work without that basic understanding of how they work, how they integrate into the body, and the other cells that they interact with. And if politicians, or we can get the message across to politicians to promote this level of understanding, then I think we'll be both better off from a funding point of view, but also from a basic understanding of how to go forward and what constitutes good evidence and what constitutes bad evidence.
All right, so with that, I think we will thank all of the speakers today. I think we're very lucky. Oh, sorry, go for it. I was going to go on to say that I think, we're very lucky that the panel here today, that the research field in stem cell biology here in Australia is very bright. So, perhaps it is alarming that there are so many, non-legitimate clinics starting up here in Australia, and per capita it doesn't look very good for us. But I think that the future is really bright, considering the types of research that's being done in this field. So please join with me in thanking all the speakers one more time for a fantastic session.